All right, welcome back to Chapter 1. Today we're going to cover Section 1.3 in statistics. This is all about collecting data and experimental design. How do we make an experimental design? So, designing a study, we need to identify the variable of interest, what we want to focus on, what the population of the study is going to be, develop a detailed plan for how we're going to collect the data. Then we have to actually collect the data. Then we're going to describe it using descriptive statistics. We're going to interpret the data by using inferential statistics, and then we're going to identify any possible errors. So interpreting that data so that we can apply it to every person is going to be the part that's most critical as we move forward. Right? Several different ways we can do this. First one talks about an observational study. An observational study is where a researcher observes and measures characteristics of interest for part of a population. For example, researchers measured the amount of time people spent doing various activities, such as paid work, childcare, and socializing. It's observing, doing an observational study. The other one that you've probably heard of before is to use an experiment. So in an experiment, we have a treatment that we actually want to see how it works. That treatment is applied to part of a population, which we call the treatment group. And those responses are observed. However, another part of the population may be used as a control group. So this is the group in which no treatment is applied. So now we can compare the two groups. The subjects in both groups are called experimental units. And in many cases, subjects in the control group are given a placebo. I'm sure you've heard that before, which is harmless. So it's a fake treatment that is made to look like the real treatment so that you can see whether or not the real treatment is working. So, for example, an experiment was performed in which overweight subjects were given the artificial sweetened cellulose to drink while a control group just drank water. After performing the glucose test, researchers concluded that the sucralose affects the glycemic and insulin responses in overweight people who do not normally consume artificial sweeteners. So that's how they know whether or not that sucralose affects overweight people differently. So there's a control group and an experimental group, and one is given the treatment and one is given a placebo. So, example, researchers study the effect of vitamin D3 supplementation among patients with antibody deficiency and frequent respiratory tract infections. 70% of them received 4,000 units of vitamin D daily for a year. The other group of 70 patients received a placebo for that year. So what is this? Well, this is clearly then an experiment. Again, it says explain your reasoning. Why? Because we have a experiment or a treatment group. And the treatment group are the ones who were given the 4,000 units of vitamin D3. The control group is the ones that were given the placebo. And then they're going to look at the effects. Now, they didn't tell us what the results were, but that's okay. We just wanted to know what kind of study this was. Right? For number 2, researchers conduct a study to determine how confident Americans are in the economy. How confident Americans are in the economy. Researchers called, so they got on the phone, they called 3,040 U.S. adults and asked them to rate the current U.S. economic conditions and whether the economy is getting worse or better. So in this case, there's no placebo, there's no additional treatment group. Everybody's getting asked the exact same question and they are just recording the answers. So this one then is observational. They are just observing. So everyone gets the same questions. There's not a treatment going on. There's not an experiment going on. There's no drugs involved. So this is literally just observing what people then say. And again, the idea is that they're going to make conclusions about the entire population based on only 3,040 people. That's what the idea behind any type of statistic research involves. All right. Here's another one for you to try. So try this one. Explain your reasoning again. Please make sure you get used to explaining your reasoning. That's going to be on your tests. All right. So data collection. How do we collect the data? Well, there are several ways that we can do that. The first one is a simulation. A simulation uses a mathematical or physical model to reproduce the conditions of a situation or process. This often involves a computer, and oftentimes it's used because it's not practical or it may even be dangerous. So it's impractical or dangerous to do this experiment in real life. So therefore, we're going to look at a simulation. It can also save time and money. For example, automobile manufacturers use simulations with dummies to study the effect of crashes on humans. Obviously, we do not want to crash human beings, so using simulations with dummies gives us information. Next one is a survey. You've seen that oftentimes in a lot of the examples that we've had so far, where you actually conduct a survey. A survey is an investigation of one or more characteristics of a population. Surveys are carried out by people by asking them questions, commonly done with an interview, internet, mail, or phone. In designing a survey, it's important to word the questions so that they're not leading to biased results. For instance, a survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. And in designing the survey, it would be acceptable to make a list of reasons and ask the individuals to select. So oftentimes it's not just yes or no, but it's going to be several options that you can pick from. You've all filled out surveys before, very much like any survey that's given. So some examples. Some experimental design. 3 key elements of a well-designed experiment. So we want to have a well-designed experiment are to have control, randomization, and replication. So a confounding variable occurs when an experiment cannot tell the difference between the effects of different factors on the variable. So sometimes things don't work out like you thought, and we have a confounding variable. For instance, a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, it cannot be determined whether it was because of the remodeling or because of the new mall. It's hard to determine which one was at stake, so you may need to do a different kind of experiment. Right. The second one then, of course, is the placebo effect. And we talked about giving a placebo, so what is the placebo effect? Well, this occurs when a subject reacts favorably to a placebo when in fact the subject has been given the fake treatment. That can happen. So they're given the placebo, but instead they act as if they weren't given the placebo. To help control or minimize the placebo effect, a technique called blinding can be used. Blinding basically is a technique where the subject does not know whether he or she is giving the treatment or the placebo. This way he doesn't have any preconceived notions of whether or not it's working. All right. In a double-blind experiment, so this is even more anonymous, neither the subject nor the experimenter knows which one is given the treatment. So whoever's doing the experimentation doesn't have all of the information, nor does the subject. So this way it's really truly anonymous, and nobody can form an opinion one way or another. Okay. Randomization. That's a process of randomly assigning subjects to different treatment groups. So you randomly just put them in a group. There's no rhyme or reason oftentimes for the randomization, but this way it helps keep things less biased as well. In a completely randomized design, the subjects are assigned to different treatment groups through a random selection. To use randomized block designs, the experimenter can divide things oftentimes into several groups, or different blocks. So for example, the experimenter testing the effects of a new weight loss drink must first divide the subjects into age categories. So he's going to look at all of the subjects. He's going to put them into 3 age categories. Then within that age category, he's going to randomly assign the one to have the control and the one to have the treatment. It's very possible that the weight loss drink works better on 30-year-olds than it does on 50-year-olds. So that's why they have to split them into different ages as well as give them the control and the treatment, the placebo and the treatment. All right. Another type of experimental design is a matched pair design, where subjects are paired up according to similarity. One subject in the pair is randomly selected to receive one treatment while the other receives a different treatment. So somehow or another they're paired up according to some kind of similarity. It may not be age, it may not be the treatment or non-treatment, but something gives them some kind of a similarity. Okay. This now is really important, and that's our sample size. This is super important. That's the number of subjects in a study, and it's very important because we want to make sure that we survey or we look into enough people. We certainly don't want people to make inferences if the experiment was only done on 5 people. Well, it's really hard to decide if a new weight loss drug is going to work if they only do the experiment on 5 people. So we want to make sure that that sample size is a valid number. To help improve the validity of the results, oftentimes we have to replicate. So we do replication, and that's required. Basically, replication is the repetition of the experiment under the same or similar conditions. So again, if you only did it for 5 people and it worked, that's great. Well, now let's do it for 10 people. Let's do it for 50 people. Let's do it for 2,000 people. Let's repeat the experiment several times under the same or similar conditions and see what happens. So, for instance, to test a vaccine against a strain of influenza, 10,000 people are given the vaccine and another 10,000 are given the placebo. Because of the sample size, the effectiveness of the vaccine would most likely be observed. That's a good use of replication. You're doing it on a lot of people in both cases, both given the placebo and given the vaccine. And so that should give you a lot of data points to pull from. All right. So let's look at some examples. A company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem with the given experimental design and suggest a way to improve it. So number 1, the company identifies 10 adults who are heavy smokers. 5 of the subjects are given the new gum, and 5 others are given the placebo. After 2 months, the subjects are evaluated, and it is found that the 5 subjects using the gum have quit smoking. That sounds wonderful. It sounds awesome. All 5 people have quit smoking. What's wrong with this experiment is that we have a very small sample size. There is no way that we're going to make conclusions, draw any kind of conclusions, convince people to take this gum in order to quit smoking with such a small sample. This makes it hard to validate the results. Very hard to validate the results. They're great results, but it's hard to validate them. So how do we fix that? Well, we're going to fix that by replicating it many more times. So we need to replicate the experiment many more times. And it may be, too, that by doing it only with 10 adults, that gives you a general idea on whether or not you think that what you've hit on is going to be a success. If you did it on 10 adults and nobody quit smoking, you may want to look for a new kind of gum. But you won't be able to validate anything till you replicate it. Right? Number 2, the company identifies 1,000 adults, so that's better. We have a little bit more adults who are heavy smokers. Subjects are divided in blocks according to their gender. Females are given the new gum, males are given the placebo. After 2 months, the female group has a significant number of subjects who have quit smoking. Well, what's wrong with this? How do we know why they quit smoking? Was it because they're just female, or was it because they were male? The males were given the placebo, so naturally the females should have had a significant number, but it doesn't tell us whether or not how that female affects the results. So basically, in this case, the groups are not similar. What you're testing on is not similar enough. So how do we fix that? Well, what we need to do then is to randomly give half the females the gum and half the females the placebo, and the same for the males, and the same for your males. So you need to randomly select half the females to give the gum to, half the females to get the placebo, and then for the males, again, randomly select half of the males to receive the placebo and half of them to receive the actual product, the gum in this case. Okay. Again, you're going to try the next one on your own. Explain your reasoning, make sure we know why. All right, next topic is some sampling techniques. How do we get the sample? Well, one way is to do a census. A census is a count or measure of the entire population. A sampling is a count or measure of part of the population. So you probably know every 10 years the United States sends out basically a survey to find our census data. We want to know how many people are in the country. We might want to know their ages. We might want to know their ethnicity. It's a long form that it's sent to every person that we have addresses for. It's usually sent through the mail. They will also even try to capture people who live in shelters or maybe even on the street so that they can get that information in the hand of everyone in the population. However, that's very, very hard to do, which is why most of the time we do a sample. And the sampling is just part of the population. However, even with all these best methods of sampling, we also oftentimes have a sampling error. So that's when there is a difference between that sample and the people in the population. So our results are invalid oftentimes, or we're not able to draw the conclusions we thought we would be able to do. And that's called a sampling error. That can occur for many different reasons, and we'll get more into that as we move into the later chapters. In fact, oftentimes you'll even hear Right now we're in the middle of presidential election or getting close to it, and oftentimes you'll hear one candidate is above the other candidate plus or minus 3 percentage points. That plus or minus the percentage points is to account for that sampling error. They can't tell you for sure, but it's going to be close. Okay. All right, a random sample is literally one in which every member of the population has an equal chance of being selected. A simple random sample is a sample in which every possible sample of the same size has the chance of being selected. I know the wording is going to get a little bit weird, but basically, how do you decide what's a random sample? If you, again, look at some of the way they poll people exiting a polling spot for an election, oftentimes they'll just ask the first 3 people that come out the door. They may ask the first person, the 5th person, and the 10th person that comes out the door. They're trying to just get a random sample. Part of that can be very erroneous because it may be that the people who are voting early in the day are very different than the people who vote late at night. So, but it's still random. Okay? So this is going to be our first example of using the calculator, because your calculator actually will allow you to assign random numbers. So how do we assign who to pick? How do we decide who to pick? In a good sample, you should have this done ahead of time. So this says we have 731 students currently enrolled in a statistics class at your school. You wish to form a sample of 8 students to answer some survey questions. Select the students who will belong in the random survey. So basically, you give every single person a number from 1 to 731. From 1 to 731. And randomly, you're just going to go basically pull that name out of the hat. That's exactly what this is basically saying, is pull a name or a number out of the hat. In this case, you're going to use your calculator. So if we take the calculator and I clear it, all right, there is a button on your calculator. It may look a little different than this because this is just an emulator. If you have a TI-83, it may look a little different than a TI-84 and very different than a TI-84 Plus. It just depends on the specific calculator you have in the looks. The buttons will all be the same. So I'm going to find the math button. When I hit the math button, then I'm going to try to find, I'm going to go over, to probability. And that very first one is your random number. So I'm going to hit 1. Then I'm going to give it some parameters. This is going to give me some random integers. Well, I'm going to go from 1, comma is above the 7 key, 731, comma. And then I want to know how many random numbers to pick. And I'm going to pick 8, hit enter. Okay, it won't let me go over to the list. All right, let me try it again, see what happened. So math, because I hit random instead of random integer. I'm so sorry. This is why we practice on the calculator. So again, this now tells me what minimum do I want to use. Well, I want to use minimum of 1. The max number. Oh, it doesn't look like it's going to let me do this. Let me clear out and start all over again. Okay, math, probability. Number 5 is the random integer. My minimum number is 1. Enter. Okay. The maximum number . not sure why it's struggling. Math, probability, number 5, 1. Well, of course it's missing a parameter. It won't let me go to the next one. Let me see what happens if I put a comma, 731, comma, 8, and now hit enter. No, didn't like that either because I got a syntax error. Well, if you're able to do this on your calculator, then we should be in good shape. Let me see if random normal does it. No, it shouldn't. All right. Well, try on your calculator and see if you can get this to work, and we'll come back. It could be that this emulator is just struggling. Your calculator should work very much like it. So again, here's the math key, probability, number 5 is random integer. I did try, and I didn't use a parentheses at the end of it. Let me see if I use a parentheses, if that makes a difference. So math, probability, number 5. Oh, okay, not that. One, comma, 731, comma, 8, enter. No, it's wanting me to get down into this column right here, into the max column, and it just won't let me get down there. I think it might just be this calculator flaw. I have used this calculator for the rest of the chapter, and this is the first time I've had any issues with it, so it should be fine moving forward. But go ahead and try it. Once you do that, you're going to enter again this information, and it is going to spit out 8 numbers. Now notice on here, we only see the first 4. You're going to have to scroll to your right to get the other 4. And so again, I want you to try this on your calculator to get some random numbers. Okay. All right. Next part of this section, and yes, this is a longer section, talks about some sampling techniques. The first one is a stratified. And this is where we divide in this. We're talking about sampling. How do we sample, get a sample group? This one talks about dividing a population into groups, some kind of a similar attribute is usually what we're looking at here. A similar attribute. Let me spell that correctly. R-I-B-U-T. All right. And then we collect it according to that information. So it says, to collect a stratified sample of the number of people who live in West Ridge County households, you could divide the households into socioeconomic levels and then randomly select households from each level. So in this case, their attribute is their income. So we have low income, we have middle income, and we have high income. And then we're going to randomly select people from that group. Again, maybe using a random number generator or drawing names out of a hat. That's just about as random. All right. The next one is called a cluster sample. And this time it divides into groups or clusters and selects all the members in one or more, but not all of the clusters. So in this example, in the West Ridge County example, you could divide the household into clusters according to zip codes, and then select all of the households in one or more of the zip codes. So if you're not interested, if maybe your experiment has nothing to do with income, then zoning for zip codes might be a better solution. The next one is called a systematic. And a systematic says you start choosing a value at random, and then choose every kth member of that population. In the West Ridge County example, you could assign a different number to each household. So every household gets a number. You randomly pick the starting point, and then you pick every 100th household. So your random number you picked was 86. Add 100 to it. The next person is going to be 186. The next person is 286, 386, and so on. So you're picking every 100th household. And then the last one is the one that we want to use as infrequently as we can. It is not recommended, and that's to choose members of the population that are just easy to get. This is often what they pick for polling places. They're going to pick the first people who cast their vote. It is not recommended, but it sure is convenient. And so therefore, some of the results will not be what you expect them to be. Okay, so let's try some examples. You are doing a study to determine the opinion of students at your school regarding some stem cell research. Identify the sampling technique used and explain again that your reasoning. You divide the student population with respect to majors and randomly select and give questions to some of those students. So you are grouping them as their major. So their major is a common attribute. They all have the same major, so that's their common attribute. Therefore, this one is stratified. So again, when we explain our reasoning, it doesn't have to be in words, like spoken words. It can be in just this thought process. Well, we put them in majors. That's a common attribute, so therefore it's stratified. Number 2, you assign each student a number and generate random numbers. You then question each student whose number is selected. So this is what we were trying to do on the calculator, was to just assign every student a number and then let the calculator randomly generate it, similar to picking names out of hats. So this is a simple random sample, because literally we are picking names out of a hat. Or if your technology works, random numbers on a calculator. I'm sorry, my calculator's not working right now. All right, and then number 3, you select students who are in your biology class. Well, there may not be any commonality between them. They may be science majors, they may not be science majors. They may be biology, they may be chemistry, they may be none of those. Basically, what you're doing is you're selecting the students because it's convenient. So this would be a convenience sampling, and literally because it is convenient to you. It made it easy. This one makes it easy. And in fact, not only are you just doing students in your biology class, but it would be students in your biology class that day. So it could be that instead of a class of 30, you only are asking a class of 10 because the other 20 didn't even show up. So this is very much convenient. Okay. And then last thing we're going to do is let you try a couple on your own. So again, decide how you would get that information, what sampling technique would you use, and then explain your reasoning. And we are done with chapter 1. Thank you.